all this. Now in this video we will be discussing about the laws of radioactive disintegration. The five laws, the fifth law being the most important law. Now the first law of this radioactive disintegration what we are going to discuss. Okay, do remember these laws were given by Soddy and Rutherford. They on investigating gave some certain laws. Once they investigated or have done their experimental study, they gave five laws, and these laws are called as laws of radioactive disintegration. The first very law was that radioactivity this radioactivity is actually a spontaneous process. That means whenever this radioactivity will happen, it is independent of external factors, like it will happen of its own. It does not depend upon, it is independent of factors like temperature, pressure, force, and so on. Like all these factors do not influence the radioactivity. Radioactivity occurs spontaneously. Now the second point is very important from the objective point of view. The second law, whenever there occurs the disintegration, like whenever disintegration happens, I can say during the disintegration of an atom, what happens, either in alpha particle or beta particles emitted, both alpha simultaneously, both alpha and beta are never ever emitted simultaneously. Whenever there occurs disintegration, do remember either an alpha or beta particle is emitted. We know what they are, we have discussed these. Is emitted. Both are never emitted simultaneously. Both of these are never emitted simultaneously. This means an atom at one time cannot emit both alpha or beta. It can either emit alpha or it can emit either beta. Not both, like both will not occur emitted simultaneously. Now do remember, an atom, suppose if an atom undergoes disintegration, an atom will only disintegrate, or it can emit only one alpha particle, or it can emit only one beta particle at one time. And moreover, do remember this, whenever the gamma emission will take place, gamma ray emission will follow alpha and beta emission. That means when there will be alpha emission, alpha particle emission, then after it will be, let's assume, beta particle emission, gamma emission will follow these alpha particle emission and beta particle emission. It means like that gamma emission or gamma alpha particle emission will not take place first alpha will take place or beta will take place, then the gamma will happen over here. Now the third law is that whenever there is an alpha particle emission, do remember, when there is alpha particle emitted, alpha particle emission, what will happen, suppose this is an X radioactive substance, it emitted an alpha particle, it transforms into a new atom. This new atom, let's say that's Y. Now let's assume that its proton number or atomic number is A and mass number is atomic number is Z and mass number is A. The new atom which is formed from this X will have mass number reduced by 4 and atomic number reduced by 2, because we know alpha particle is actually has 2 units of charge, and it has 4 units of mass. This is what we know. Now coming to the fourth law, this is, suppose if there is beta particle emission, this is beta particle emission. When a beta particle emission happens, suppose if this is X, it will not change like the way in case of alpha particle, it will transform in a new particle, but in this case the mass number is reduced, like mass number is not reduced at all. Let's say it is A and atomic number is Z. In this case the atomic number will be increased by 1 rather than the mass number will be same. So these are the four important laws which are generally asked. Any question can be asked from the MCQ point of view. Now the fifth law is the most important law. Let's come to the law number 5. This is what we call as the radioactive law or radioactive decay law. This is very important. We just simply call this as decay law. This law states that the number of atoms disintegrated per second at any instant is directly proportional. It is directly proportional to the number of radioactive atoms which are actually present in the atom. Let me make this law very simple. In that particular sample, let's say I have two samples X and Y. Suppose at particular instant when time was equal to 0, when the radioactivity has not started, let's say this sample had 100 number of atoms, radioactive atoms. This Y sample had 800 atoms. Let's assume this radioactive decay law says that when this decay will happen, it will happen more faster. As it has more number of atoms, radioactive atoms, it has less number of atoms. The rate of disintegration, I can say rate of disintegration, that is the disintegration with respect to time. Rate of disintegration of Y will be more than X. This simply means if we have two samples, the sample which has greater number of atoms, sample having greater number of atoms will decay at a faster rate. It will decay at a faster rate, or vice versa, the sample which has lesser number of atoms will decay at slower rate. Generally, when we describe this decay law in terms of equation, we generally say that, and we define this rate of disintegration as, we simply define this rate of disintegration as R will be equal to minus dN over dt. D over dt is nothing but the rate of change, and minus indicates the number of atoms that are left undecayed. Let me give an example. Suppose if an atom, when the radioactivity started, is about to start, when it has not yet started, if it has n naught, this is the number of atoms originally present, which are originally present when the radioactivity has not started. Now let's say after time t, the remaining atoms, the number of atoms which are undecayed, dn is the actually the number of atoms which are present in the sample. Actually they are the, I can say they are the number of atoms which are undecayed. Now let me give an example. By the help of the example we will understand. Let's say I have a sample, it has 100 number of atoms present originally when the time, let me give a sample. This sample at that time when the radioactivity has not started is 100. So this 100 will be nothing but n naught. Let's say after 10 seconds, the number of atoms in this which are left is 40, or I can say 60 atoms has decayed from it. So how many are left in it? It is only 40 are left. So 40 which are left, if it is mentioned that 40 are left, that 40 is nothing but that is actually n. So n naught is the number of atoms which are originally present, and n is the number of atoms which are left over after time interval t. Now once we derive, if we have to calculate the number of atoms present, it is equal to n naught e to the power minus lambda t. Now we know everything in this formula, that is the what is n naught. Let me write it again. N equals to n naught e to the power minus lambda t. So in this case, n is the number of atoms which are originally present, n naught is the number of atoms which n naught is the number of atoms originally present, n is the number of atoms which are undecayed, and here comes a new term, that is what we call as lambda. Lambda is nothing but it is called as decay constant, or we can say the disintegration constant. This is called as disintegration constant. Now one important point generally that you have to remember, suppose if I'll say that time has gone infinite. Let's say here and I have taken time as 10. When the time is infinity, in that case n becomes equal to 0, because all the atoms in that case are totally disintegrated, so there is no atom left in that case. So if we will understand this, we can just have like this decay constant. This decay constant is generally represented as 1 over t, and it has the units of either you can say per second or per minute. It depends upon the material, or we can say the substance. It can be also day inverse, or it can be also year inverse. So this was the case of radioactivity, laws of radioactive disintegration. Now we do have a simple last point over here. What is the significance of this disintegration constant? What does the information that disintegration constant gives us? Suppose if I have an x sample, y sample, and this has lambda or the disintegration constant more, and this has less value. Do remember, when lambda is small, that is the radioactivity decay constant is small, what we can say, the radioactive substance decays slowly, or we can say when lambda is large, the decay will occur rapidly. So this is all about the 5 important laws. In the next video we will be discussing about the half-life. We will be discussing about average life of the radioactive substances. Thank you.